Hi everybody. In this lesson we want to look at some cube roots and understand what we mean and see the difference between square roots and a cube root. So here we have the cube root of 8. When we write the little 3 here and sort of the side of the radical symbol, we call that the index. So this has an index of 3, and 8 is of course the radicand, just like it was for the square root. So if there's a square root, we could also put a 2 right here for the square root, but square roots are used so commonly that we typically omit that. And so if there's no number there, then we understand it to be the square root, but any other number, cube root. And this means the number that I would multiply by itself 3 times to get 8. And that number is 2, since 2 to the third power, 2 times 2 times 2 is equal to 8. Now, if I had negative the cube root of 8, that would mean find the cube root of 8, which is, of course, 2, just like we did in this example, and then stick a minus sign in front of it. So that's going to equal negative 2. And the cube root of negative 8, well, you remember if I had like the square root of negative 4, that was not a real number, because there's no number you could square to get a negative number, in this case negative 4. But the cube root, because it's an odd index, that will actually give me a negative 2, since if I cube a negative 2, that does give me a negative 8. Okay? So I can take cube roots, in fact fifth roots, any odd root of a negative number, but I can't take square roots or fourth roots or any even root. Okay, so let's do another example here. Here's a function. G of x is the cube root of x minus 3. So if I'm asked to find g of 67, that would be the cube root of 67 minus 3. So that would be the cube root of 64. And so I have to think, well, what number do I multiply by itself 3 times to get 64? Well, 2 times 2 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed, 4 times 4 is 16 times, times 4 is 64. So this is going to be 4. Again, that's because 4 to the third power is 64. G of negative 24, well, that would be the cube root of negative 24 minus 3. That's the cube root of negative 27. Now I can take cube roots of negative numbers. If this had been the square root of negative 27, that wouldn't be a real number. But the cube root of negative 27 is going to be a negative 3, since negative 3, the whole quantity cubed, is negative 27. Now I also want to just bring to your attention, up here when we did the cube root of negative 8, and that was negative 2, and minus the cube root of 8 is also negative 2. They are the same answer, but they're the same answer for different reasons, right? Here, negative 2 is the number I cubed to get negative 8. Here, 2 is the number I cubed to get positive 8, and then I stick a minus sign in front of it. All right? If I wanted a g of 8 down here, that would be the cube root of 8 minus 3, which is a cube root of 5. Now 5 is not a perfect cube. I know that 2 cubed is 8 and 1 cubed is 1, so I would guess that this is going to be 1 point something. 1 point something times itself 3 times to give me 5. Well, I can figure that out on my calculator. If you have a graphing calculator, under the math menu right here, there is a cube root button, and that would be number 4. So I'll take the cube root of 5, and that gives me, somewhere a little smaller than 2, 1.7099, blah, blah, blah. Okay, and it's going to be an irrational number. It will never terminate. It'll never repeat, so I might want to just, round that off at 1.71. Okay. All right, now let's look at the graph of what a cube root function looks like, and you can compare that with what we found in a previous lesson about the square root. So let's plug in some numbers. Let's start with 0. 0 is my favorite number to plug in, and the cube root of 0 is 0. that would give me the ordered pair 0, 0. If I plug in 1, I can take the cube root of 1. That's 1. That's going to be this point. And the next nice number to plug in is actually 8. If x is 8, the cube root of 8 is 2. So let's see, 2, 3, 4, 5, 6, 7. Here's 8 out here. And if I wanted to do negative numbers, I can take the cube root of negative 1. That's negative 1, because negative 1 times itself 3 times is negative 1. So that's this ordered pair. If I plug in negative 8, the cube root of negative 8 would be negative 2. So if I come all the way over here, 2, 4, 6, 8, that'd put me right here. Okay, and maybe another one. Let's plug in, like, say, 1/8. Notice the cube root of 1/8 would be a half, because a half times a half times a half is an 8. So this would be like a half, and then this would be a quarter, and half, that'd be an 8. So here's an 8 in the x direction, and then it's up a half. And likewise, if I were to plug in a negative 1/8, that would give me negative a half. All right, so here's what this looks like, and we could plug in some more, but we'll just see if I can do this halfway decent. Okay, so that's going to go up and cross right here. Maybe not quite that. There we go. Okay, so notice on this graph of the cube root function, you can take cube roots of both positive and negative numbers, and so your domain here is going to be all real numbers from minus infinity to infinity. This whole x-axis here has graph paired with it. All right, and then notice I'm also getting out positive and negative numbers. And this arrow shows it's going to keep going up, and so every one of these y values is also going to be hit, and so my range is also going to be minus infinity from infinity. Okay, so right away I think you're seeing, I hope you'll see that the cube root functions are actually nicer in the sense that you don't have any of those domain restrictions that we had with the square roots. Let's do one more example right here. If I had the cube root of negative 27x to the 6th, then I want to think to myself, well, what could I cube to get negative 27? Well, that would be negative 3. And then what would I cube to get x to the 6th? Well, that would have to be an x squared, right? And again, that would be because if I take negative 3x squared and cube it, I'd have to cube the negative 3 to get negative 27. And when I cube x squared, that's x squared times x squared times x squared, or you multiply the exponents, and that gives you the x to the 6th. Okay? One more problem with the domain and range. Suppose I'm looking for the domain and range of this function g of x. And again, you can graph it. I've graphed it here on my graphing calculator for you. And because it's a cube root, I don't have to worry about the radicand being strictly greater than or equal to 0. The radicand here can be anything. And so you can also see that illustrated by the graph over here. Every one of the x values has graph paired with it. And so my domain is going to be all real numbers from minus infinity to infinity. And then my range, when I look at the y values here, even though this looks kind of flat, it's not totally horizontal. It's actually going to keep going up. And so every one of these y values is also eventually going to be hit. All right, so it may not be obvious from this graph, but if you were to extend your graph out to, like, say 1,000 on both sides, at least in the x direction, then you'd be getting up close here to 10 and down here to minus 10. So anyway, the range there is going to also be minus infinity to infinity. Let me just take a minute and show you that on my calculator. If I were to graph this, so if I go, let's go to the math menu, and let's put in the cube root oops, I need to get to my y equals here. So let's go to the math menu and we'll find the cube root of 2x minus 6. Alright, and let me just graph it on my standard window here so you see the graph that we have on our page. So it looks like that. But notice if I were to go and change my window, let's go from, like, say, minus 1,000 in the x direction to 1,000 in the y direction. And I'll make my y scale here be, like, say, 100. Okay? And I got to go back and correct this one. Put an extra 0 in there. Okay. But I'm going to leave my y between minus 10 and 10. Alright, so here you can see that, yeah, it really is going to get all of my y values there. So this here, if I trace along here, you can see that, see, this is 148. So at 148, my y value is 6. At 319, my y value is up to 8.58, and so on. Okay, so it really is, if you extend far enough in the x direction, you'll get some bigger y values than what I was getting over here. All right, the domain is minus infinity to infinity, and the range is again also going to be minus infinity to infinity.